API, which first of all wasn't the most intuitive. Second, to dig into something called correlation, data frames, and dataset. Some time ago, when you wanted to write application which do something with the data, that data will be read into something which is called RDD, resilient distributed data set. And resilient means that it's immutable, meaning once created, it cannot be changed. If we would like to do something with the data, then the new RDD will be created. And this strange behavior helps Apache Spark to achieve fault tolerance. And then our application would interact with the data, as we are going to see in a second, through the RDD API, which first of all wasn't the most intuitive. Second thing, it wasn't the best optimized. And then the driver under the hood would take that RDD, split it into the partitions, and then assign tasks and partitions for the executors. Since 2015, we have two new APIs available for us. It's called Structured API or Spark SQL. One of it is called Data Frame, and we can use it in all the languages. SQL, in the second. And there you go. When you want to, and that's another frequent questions on the Databricks exams or Spark interviews. Let's talk about RDDs, data frames, and dataset. Some time ago, when you wanted to write application which do something with the data, that data will be read into something what's called RDD, resilient distributed data set. And resilient means that it's immutable, meaning once created, it cannot be changed. If we would like to do something with the data, then the new RDD will be created. And this strange behavior helps Apache Spark to achieve fault tolerance. And then our application would interact with the data, as we are going to see in a second, through the RDD API, which first of all wasn't the most intuitive. Second thing, it wasn't the best optimized. And then the driver under the hood would take that RDD, split it into the partitions, and then assign tasks and partitions for the executors. Since 2015, we have two new APIs available for us. It's called Structured API or Spark SQL, to underpin the tolerance. If we would like to do something with the data, then the new RDD will be created. And this strange behavior helps Apache Spark to achieve fault tolerance. And then our application would interact with the data, as we are going to see in a second, through the RDD API, which first of all wasn't the most intuitive. Second thing, it wasn't the best optimized. And then driver under the hood would take that RDD, split it into the partitions, and then assign tasks and partitions for the executors. Since 2015, we have two new APIs available for us. It's called Structured API or Spark SQL. One of it is called Data Frame, and we can use it in all the languages. Another one is something that we can use only in Scala. It's called Dataset, and this is basically the higher level API, meaning it's first of all, it's more intuitive, kind of looking like a SQL API, which is basically easier and faster to use than RDD. And the second thing, whenever we are using data frames and dataset instead of RDD, everything what we are going to write is being optimized by Catalyst Optimizer, and this is a big advantage over the RDD. We can still use the RDD API, but nowadays it's being considered as the low-level API. It gives us more control, but it's less intuitive, and it's not optimized by Spark by default. But we are going to see that in action. And we are now in the second notebook about RDDs, data frames, and datasets. As understanding of those is important to understand Apache Spark architecture. Cluster is the same, many things are the same. What is changing is the dataset. So our task for that notebook is to use three of those, RDDs, data frame, and dataset, and find, using each of that, number of taxi trips per number of the passengers. And this is our dataset. Is the same as previously, just previously the files were compressed. And for the sake of making that easy to read into the RDD, I made a copy of one of these files, just it's uncompressed and it's ending with the CSV. And the data looks following. The logic behind it is not so important. The only thing worth paying attention to is the fourth column called passenger count with the number of the people in the taxi per trip. And now let's go straight to the, first things first, and I need to prepare a setup. And now let's go straight to the RDD. So this is a reading and grouping and counting the data using the RDD. So at the beginning, this is the first difference. Previously, we were using a Spark session. In order to read the data into the RDD, I need to use something what is called Spark context. Then I'm using a function text file where I'm specifying, of course, what I want to read. And then we are going to see filters, maps, and
Spark context versus Spark session is a unified high-level entry point, blah, blah, blah. as a legacy low-level entry point that connects user directly to the Spark cluster. Think of Spark session as a convenient wrapper that completely encompasses Spark context while also combining. Okay. High-level data abstractions. Okay. So Spark sessions are the new things. Okay. Or create the wrapper of a Spark context. Only one active multiple concurrent users can share one JVM. Okay. Some possible require Spark session to establish the underlying relation to the users managing creating low level RDDs, right? Is a modern gateway design, providing single which is partial intersecting vehicle. Okay.
Reduced by key. So I'm filtering the rows and eliminating the row which claims vendor name. And the reason is because that's the first row which I don't want to take into my calculation. So I need to filter it in the RDDs. Then for each row, I'm splitting the data using a comma separation. And done with map, I'm taking the fourth column and reducing by key just to generate a group by. And then I'm returning a final results to the variables count and trip count. And then I can print it. So let's press Control Enter and see how this looks like in action. So you can see that it's not really a SQL-like. It requires from you to learn the new concept when you want to use the RDDs, like those filter maps, which is more a functional programming style, not a SQL. But anyway, here comes the Spark job. And what we are going to see is that now we are going for the first time, we are going to have one job with two stages. Previously in
Scheduling resource allocation. हाँ अब शायद इसे समझ पाऊंगा. I should have listed for driver boxes, which is where the high level span. Now it has been secret executive which is of lifestyle. It's in what's in diagram what's in some level secret. Okay. Okay, and Spark and several Spark applications. Right. Several applications. Since and internal multiple concurrent job will respond to each action called on an RDD in a given application. And this section is Spark application of the concepts. That process concludes the library transformation in addition to Spark's scheduler, especially uh, sharing resources and if your job is trying to run very big clusters overload so static allocation and dynamic allocation. As long as Spark context is still running. I think Spark context was the legacy API and Spark session was something that they used later. Yeah, Spark session is the newer API. Okay. Now it's going to dynamic allocation is available for almost all jobs. Um, In addition to Spark search, to resource allocation, there's more Spark's added resource to support algorithm functions with Combo GP, specialized hardware will explore resource files and appendix T. A. picking these executors from the cluster manager. When because different sizes for executors is needed in this, we can Spark context as one set of configuration parameters for running Spark jobs. These parameters are exposed in the Spark conf object, which is needed, which is used to create a Spark context application context. Response is that is each Spark program running on a cluster likely is one Spark context. Okay, RTDs cannot be shared between applications with transformations such as joins that use more than one RDD must have same Spark context. Var meaning of R RDD that results in uh, that results in what results in another struct creates another uh, not another, it's a new copy. It's not new copy of RPT RDD can't be shared. Imagine share across apps. So basically basically join, count, these are wide transformations. Any transformation any transformation that depends upon the context besides the one present in its own Spark shuffle object is called a wide session. For example, if we are just doing a simple map function, right? Map function as in key, okay, given some string value in a column, we just want to count how many like letters are there in a string. So maybe we can have a function like this map, right? Count letter. So to calculate this, we do not need any information about any other row present in this column. So this is a narrow transformation. So any narrow transformation can be done without sharing this additional context. But अगर हमें wide transformation करना है जैसे count या join, there we need information कि अच्छा कि like how many total letters are there, right? So एक ये होगा ऑपरेशन, एक ये होगा ऑपरेशन, इन सब में हम letters काउंट करेंगे, right? तो इसके लिए basically you'll be creating some new data set after this operation has been completed. So this won't disturb the initial RDD. It will instead create a new copy, right? It will instead create a new copy of an RDD, RDD1, RDD2 with this pointer that basically has some property that defines what operation was conducted on RDD1 to get RDD2. Okay. This is how an executor cannot span multiple nodes and RDD will evaluate across multiple executors. Okay. Partition cannot be spread across. multiple executors, Spark driver, cluster manager, Spark tag. Okay. Oh, so cluster executor, right? So basically, every Spark job goes through this cycle. There is a driver. Driver is nothing but the parent machine, and it takes some partition of the RDDs. RDDs are like you can they are very isomorphic to a data set. Not exactly a data set, but they can be considered as isomorphic to data set. Uh, so drivers, this parent driver takes a copy of this data set, some portion of it, and allocates it to an executor, right? A executor is part of a cluster machine, right? So if a cluster has say 4 cores, then this will have 4 such executors, right? So the number of concurrent ops is equal to n clusters time cores per clusters. So if we are trying to profile and in the Spark view, we don't see these number of concurrent processes happening, right? There might be some process. So given this is a time axis, some processes might be faster depending upon what partition of the RRD they have received, right? So some process might be faster, some processes might be slower, but uh, at a time there should at least be these many number of concurrent processes that are happening. That was the idea that he just shared earlier. Okay. Default Spark scheduler and concurrent actions. Okay, so I'm just done with that. Talking about this right now. White transformation. We just talked about them earlier. Stage is composed of one or many tasks that corresponds to parallelizable unit of application, and let's there is one task for each partition. In the resulting RDD of that stage, Spark context Spark session. Okay, action, collect, save, text file, white transformation, sort, group by, configuration, given partition, that I
all other examples, we were having multiple jobs, and in each job, we were having mostly one stage. Here we are having one job with two stages, and in each stage, we're having 5 tasks. So let's take a look on how this looks like in the Spark UI, job number 28. So let me open Spark UI, and here I have a job number 28. So let's take a look on the details, and we can see that something what is called DAG visualization, which we will explain, is showing right now 2 stages, and those 2 stages are connected. What means that there is data exchange happening between those 2 stages. And let's say that I would like to look into the further details, but using the SQL data frame tab. Here's the surprise waiting for me. There is no entry for the job number 28. So our job was number 28, and there is no entry here. And the reason is obvious. The RDD is the lower level API, not the higher level API, and that tab is dedicated only for the higher level aka SQL API, meaning whenever you're using a data frame, data set, or you will be writing a SQL in the databricks, you will have entry here. But if you will be using the RDD, which is lower level API, there will be no information about that over here. So the only information you can read about your application, in case you are using RDD, will be in the jobs or stages, which is natural consequences of Apache Spark architecture. So let's get back to our notebook. So that's how reading and grouping the data looks like in RDD. So we see that it's not so really intuitive. And now let's use a data frame. And with data frames, it's completely different story. It's basically day and night. So first we are reading the data using Spark session, Spark read option. And here we are reading straight away header. So it's simple as that, and specifying where the data we want to read is located. And then we are doing a SQL-like group by end count, which is fairly intuitive for everyone who knows SQL, and doing a show. Control Enter, and we can see that the application structure is immediately different. We are getting 2 jobs at this moment, and each job is having only one stage, this stage with 16 tasks. And we also get a third job with 1 task, and that's the results. And if we move back to the data frame SQL tab in the Spark UI, we are going to see those jobs over here, and we can investigate further details in the already familiar for us way. So that's basically what was happening. We were scanning CSV, doing the partial grouping, exchanging the data, and exchanging the data. What is important to say is that whenever we are exchanging the data, Spark is repartitioning the data which we are exchanging, and the default number of the partitions Spark is always trying to apply is 200. But then optimization, Spark optimization, which we'll be discussing later on, kicked off. It's compressed the number of the partitions to 1. It's performing the final grouping, and then the results goes to the API data available in the SQL/data frame. And the third thing is that one of the reasons for having multiple jobs with one stage over here versus one job with multiple stages in case of the RDD is that because of the data frames, there is a lot of optimizations happening, like catalyst optimizers and others, which we will discuss later on. So whatever we are doing in the data frame, it's way more better optimized than whenever using RDD. So the RDD is harder to use and it's less optimized. And now let's take a look on how the things looks like in dataset. So datasets are available only in Scala. So I need to define that starting from now, I'm going to use Scala as a language. And let me start from the second line actually. So here I'm defining value dataset in the typical for Scala way. And then I'm using exactly the same way as in case of the data frames, Spark read option, CSV, and the and I need to define the data structure, which I'm expecting for the type safety purpose. And that's a big difference. So talking the structure, the data, and in the first job, we are going to get 2 stages. One will be script. If we go to the Spark UI and let me refresh, expecting, we achieve the type safety, and that's really the big difference.
Okay. Spark handle DAG of stages. When it's mentioned in this market, this is called DAG scheduler. As you have probably noticed, it is have to do with connecting to your cluster as your configuration parameters or launching a small job. It's from the national development as well as I have to do with connecting to your cluster as well.
You waited and debated while you waited to sabbatical. Bound to rock your body as we turn the party radical. I can see the game like the blind feel the pain. Sides come at 'em with the concrete and rain. The Pacific Northwest take the spotlight now. My people pump your fists like your Manny Pacquiao. Man style with the wild style, right to be hot style. Folks feeling like a rob holler in a dark town forward. In this generation, right? Believe even wax town boy speakers put up for me. It's up to me.
Nah, I think बिना म्यूजिक के ज़्यादा अच्छी. Spark Job is the highest amount of the Spark session execution hierarchy. Each Spark job corresponds to one action, and each action is called by the driver program. Spark application as. Why is anyone even watching this? Okay, Spark job. One way to conceptualize an action is something that plays out of your RTD or Spark into some of these choices are usually by bringing data. Driver writing some stage to the system. It is a Spark execution of based fundamentally between the partition of the armor transaction is an operation that returns something like a RTD cannot have any children. Okay, okay.
It's up to me.
More.
Welcome back to our PySpark tutorial series. They provide a distributed
AI नहीं.
Hello and welcome back. Before we can jump into coding and do our hands-on with Spark, we need to understand a few more important topics, such as partition, transformation, action, why Spark prefers lazy evaluation, and Spark. We are going to deep dive into these topics. To start with, let's understand what's partition. So to allow executors to work in parallel, Spark breaks down the data, what we call the data, into chunks, which is known as partition. If you remember our last example, we had bag of labels, and the variable was segregated into pouches. In this example, you can consider these pouches as partition. So according to this example, our data was partitioned into 4 partitions. Now, this 4th partition of data can be executed by 4 tasks in parallel. This allows Spark processing activity. Now let's understand what are transformations. Transformation are nothing but basically the instructions or code that we supply in order to modify or transform our data. The examples are select, where, group by, and the transformation helps Spark to build up the logical bit. There are basically 2 transformations, narrow and quick. Consider this example. We have an employee data set where we have to do certain transformations. Like first, we have to select only those employees who have salary greater than 10,000. Then we have to select only the name and salary from the data set. And the third transformation that we do is we do a group by on the employee data based on the different. If you see, this whole workflow is a type of logical plan that is designed to start from the data set which is employee and end the data set which gives us the group by data which is required as the final output. So this is how transformations written where we have where as a transformation, select as a transformation, and group by as a transformation. So what is a narrow and a wide transformation? Consider you have data partitions. Now, this data partitions contribute to only one data partition. Similarly, the second one also contributes to almost one. The third one also contributes to one. This type of transformation is known as narrow transformation. In case where one partition can contribute to more than one partitions like this partition is contributing to 3 partitions. Similarly, the other one is also contributing.
Actually, this is wrong. Uh, okay, so yeah. So this person has said that a one-to-one, like a narrow transformation should have a one-to-one mapping between the input and the output cell. But that's not really the case, right? You can have more than one input for this operation. It's just that the the cells that are used to produce this output should not be dependent upon their individual value, right? For example, an operation that basically takes cell C1 and simply adds C2 to return this uh, output cell O1 will always use C1 and C2 no matter what values there are. But if there is a condition where C2 is only selected, C2 is only selected if C2 is above some certain threshold, else it's zero, right, to produce O1, then this will be a wide transformation, right? Therefore, it's not completely correct. There can be many to one relationships between in a narrow transformation as well. It's just that the value should the connection should not depend upon what exact values there are in these cells. Okay.
This type of transformation is known as white transformations. Now, as you can see in the example, data from one location is moved to multiple locations. This is what we also known as white transformations lead to actions. We already understood transformation right now. In order to execute a logical plan, what transformation creates, we need actions. Actions basically trigger execution. There are basically three types of actions. First, to view the data in console. Second, to collect the data in native languages. Third, if we write the data in output data sources. So we just discussed transformation and action. But what is the use of transformation in native languages? Third, if we write the data in output data sources. So we just discussed transformation and action. What is the use of transformation and action? Basically, Spark prefers lazy evaluation. It means Spark will wait till the result moment to execute its computational graph. And what is this computational? This is the transformational logical plan that was created. And when an action is called, the transformational graph gets executed. Spark will wait until an action is called. Why this is necessary? This is necessary for Spark optimize and plan the resources properly. This also leads to executional benefits. Let's understand with this. Consider you have a sandwich and a customer comes to you and asks for a sandwich. And he asks for a white bread sandwich at first. You start preparing the sandwich and the customer changes his mind and asks for a brown bread. What will happen? First, you will waste your time on that white bread sandwich. Second, your white bread is wasted, which is your resource. Payment is done, the order is locked. Now you know what the customer wants. What is this is what is called lazy evaluation and lazy evaluation. And the last topic today is what is Spark session. So if you remember that example, the instructor was the driver, and that driver process is Spark session. Spark session is basically the entry point for the execution. Spark session is responsible to execute code in cluster. And for one Spark application, there can be only one Spark session. Don't worry, if you're still confused about Spark session, we still have hands-on sessions. We'll see Spark session elaborately in our hands-on session. Let me understand what are applications, what are transformation, how
Okay. Journalism. We just read about this. Okay, recall that Spark lazily evaluates transformation. Transformations are not executed until an action is called as mentioned previously. A job is defined by calling an action. The action include one or several transformation. And by transformation, define the breakdown of jobs in the stages. A new stage begins whenever network communication between workers is required. For instance, in a shuffle. Okay. these dependencies. Path mechanism transmit data across different partition and execution nodes. It triggers a wide transformation in compression and which require data to be grouped together for processing if it involves binary process and it is an expensive operation. Shuttles optimize capacity. Okay. In fact, Shuffle is the exact one where data locality is broken while present data distribution of databases. So locality like map side aggregation, local detection before any data moves over the interface mark performs local calculation which can be executed. Okay. Adaptive query downstream shuffles source types. Okay. States and swallow this transformation require a shuffle. Okay. Then each executor can apply the flat map and filter steps consecutively in one pass of the data. Sparky flags up how RDDs partition so it doesn't need to partition the same RDD by the same practitioner more than once. This has some interesting consequences for DAG. Yeah, this was the optimization I was talking about. Yeah, Spark keeps track of how RDD is partitioned, so it does not need to partition the same RDD by the same partitioner more than once. This has some interesting consequences for DAG. The same operation on RDDs with known practitioners and RDDs without the using the different stage one place because there is no need to shift an RDD. Okay, cool. Because the stage possibility is equal to aggregate level still RDDs when conservation is just fine. However, the wide distribution need to complete one RDD. Okay, so fewer wide operations are required. The task at stage consists of tasks that tasks simultaneous action in the execution hierarchy. This was part of the databricks Spark exam that I was taking earlier today. A task is the smallest execution unit in the execution hierarchy, blah blah blah. And each can represent one local computation. All the tasks must also same for different piece of data. So task is like a SIMD operation. Okay, one task cannot be executed on more than one executor. However, each executor SIMD is nothing but okay. So to get a clarity about SIMD, it's like this. SIMD operations. Uh, it's a vectorization approach. approach, right? Here, a single piece of instruction, maybe it could be addition. It is given to a large set of data set, different, more than one piece of data set. And rather than having a different instruction for all these operations, right? Operations to produce this final output array, each operation is same. So single input, I forgot the full form of SIMD. One single instruction, multiple data. Yeah, so same instruction typically works on multiple data. That's the idea of SIMD. Okay, yeah, it's fair enough. So, mm, one task cannot be executed on more than one executor. However, each executor has dynamically allocated number of slots for running tasks and may run many tasks concurrently, so it's like the number of tasks per stage corresponds to the number of tasks per stage corresponds to the number of partition in the output RGB. Okay. These are the inefficient operations, not this. Uh, Anything that starts with stage is an aggregate operation, and that's why for function like group by and sort by key, you will see that they have this stage prefix before them. That's because they trigger a wide transformation that requires a shuffle between different RDDs, while operation like map uh, can be can be performed using the same data locality, right? So they are more efficient since there is no data movement over a network bandwidth, which is a lot slower than the internal computer bandwidth, right? Yes, this is okay. Stage blue boxes are bound by shuffle operation, group by key and sort by key. Please do. RD dot filter at map, filter map task, okay. Task, okay, that is to say, in a particular executor, there is a staging operation, right? For example, in stage one, we have a filter and a map, right? So if there are multiple stages that are required for the completion of this program, this is stage one, this is stage two, there is stage three, then these stages themselves might not work in parallel, but the within these stages, task within these stages, as mentioned here, right? As mentioned here, wait one moment, amazing. Uh, so the task mentioned here they work in parallel. And task is nothing but the number of partitions in the RRD. Okay. Thus, you cannot necessarily learn every task in parallel. For each stage, each executor has a number of core. So basically, if there are, suppose, uh, m tasks, right? M tasks, and an executor has C cores, to the number of concurrent processes are equal to minimum of C comma M. Okay. Dinner time. Thank you for joining. Bye bye.